Welcome back, Physics 30. This is the second part of the Part C booklet. So hopefully you had a chance to do these questions. And we'll look at number 14 here. Describe some hints that can be used when determining equivalent resistance in a series parallel combination. So there's a couple of really good hints here. You should start this. The first idea is to start furthest away from the battery and work towards it. That's one of the biggest keys there to figuring this out. And we'll look at a couple of examples in question 15 below here. Then draw loops around the series resistors, and so once you start furthest away, see if you have any series resistors and determine what that equivalent resistance would be when you combine them. Then re-sketch that section, replacing circled resistors with one resistor. Identify parallel resistors by drawing loops and calculate the resistance. Replace with one resistor, so on and so on. Then figure out the series, then figure out parallel, series, parallel, etc. So we'll take a look at what this looks like here when doing a couple of questions here. These are from page 87 of the Duotang. Questions 1 to 4 we'll look at and see how we make out. So first of all, now just pay attention to the blue one. Like, I realize I have this somewhat cluttered here, but look at the blue one. This is the original question. So we have a battery going through an 8 ohm resistor, then it's split off into a parallel branch where there's two 6 ohm resistors, come together to a 7 ohm resistor, and then come to the battery. So first thing we need to do is start furthest away from the battery and work towards it. So the furthest away is this branch here. And in this branch here we only have a 6 ohm resistor, so there's nothing we can do there. It's just 6 ohms. Draw loops around the series resistor. Okay, we did that. There's nothing there. Resketch. Okay, we can't. Now work your way towards the battery. Here is the parallel resistance area. So in this area I'm going to figure out what would two 6 ohm resistors in parallel be equivalent to if I had to make one battery. So I'm figuring out the total resistance in this circle right here. So 1 over RT equals 1 over 6 plus 1 over 6. So 0.166 plus 0.116, 0.3 repeating. Interchange here, it's 3 ohms. So two 6 ohm resistors in parallel is equal to one 3 ohm resistor. So think of this as just a 3 ohm resistor, and I redraw it. 8 ohms, 3 ohms, 7 ohms. And now the question's easy because in series circuits the total resistance is just equal to the sum of the individual resistors. So 8 plus 3 is 11 plus 7, 18 ohms. There we go. So what I'll do is I'll get you to take a look at the next ones. If you need some hints, don't be afraid to come and see me. I think these are the final answers. I can't remember if you have the final answers in the Duotang or not, but I think these are the answers here. So number 2, I think I might have skipped a few steps here. I think the final answer is 4 ohms. For the third and fourth one, the third one, total resistance is 22 ohms, and the total resistance is 4 ohms for number 4. Okay, so if you're running into a snag, please feel free to come and talk to me, and we'll give you some more hands-on help with figuring these out, because you can only go so far in the video. Okay, the next one here. So the following questions involve Kirchhoff's laws as well as equivalent resistance rules for series, parallel circuits, etc., and combinations. So here we have bringing everything together that we learned in the whole booklet. Okay, I'll maybe go over 1 and 2 with you here, and then I'll leave the rest for you. I like to give you a sheet that has the final answers on it so you can check to see how you made out, and then hopefully you can go from there. So basically we need to figure out everything that's unknown here. So we're given the total voltage, it's 90 volts. We're given R1 is 12 ohms, and the current going through here is 4.5 amps. And we need to find all the other missing pieces. So basically Ohm's law, V, I, and R, V, I, and R, V, I, and R. We're going to look at all of those three. Okay, so first of all, if I look over here, I just simply called it VO. That means the total branch 1 here. I have R, and I'm looking for I and V, and then V2 deals with resistor 2. Now, one thing that we should notice here from our rules is that if I know the current going through here is 4.5 amps, in a series circuit, the current is the same everywhere. So if my I2 is 4.5 amps, my I1 is 4.5 amps, and my total current is 4.5 amps. So all of that is 4.5. So you have to look back at those rules. You may want to summarize those rules just on a piece of paper for series circuits, parallel circuits, and so you have them in front of you so you can easily access them. So if that's true, if that's true, then 4.5, I can figure out what V is right here. I times R, 4.5 times 12, 54 volts. Okay. Now, if I know that I used 55 volts of energy here, my total was 90, use up 54, I can get the remaining part that I'm going to be used up through here because the total voltage drop must equal to the total voltage to begin with. So that must be 36 volts going through here. Then, of course, if I know V2 and I2, I can figure out R2. V equals I times R, or R is equal to V divided by I. So that works out to be 8 ohms. And of course, we know that the total current is 4.5 amps. Also, the total resistance, I have 12 ohms here, and I figured out I had 8 ohms here. So the total resistance on the whole circuit, of course, 12 plus 8 gives you 20. And I keep skimming the pages here. Okay, so that's kind of an example of a series circuit. Look at a parallel one now. So I think number 2 involves that, and I think 3, 4, and 5 deal with combinations of series and parallel. So here we don't know the total voltage, we don't know the total resistance, we don't know the total, we do know the total current, it's 15. And we're told here that going through resistor 1, the current going through there is 6 amps, but we don't know V or R, and the voltage drop here is 120. So there's a couple of things we know here right off the bat. We know that in a parallel circuit, the voltage that is initially applied to all the electrons must be completely used up. So if the voltage drop here is 120, electrons go through that. If they chose to go through that loop, that means they must have had 120 to start with, and that going through here must use up 120 as well. So my V1 must be 120 volts. And if I know the current is 6, and if I know the voltage drop is 120, I can figure out R, as you can see here. V is equal to I times R, or R is equal to V over I, so that's 20 ohms. Okay, and let's see here. If I know that 6 amps are going through here, I initially started with 15, 6 this way. Of course, the difference must equal the current that's going through here, because remember, the rule is the current must add up through each of the loops to be the total current. So that's 9 amps going through here. Now that I know that it's 9 amps, I can figure out R2, the resistance of this circuit, because I know V, I know I, so rearrange it, I get 3.3. Okay, the total current returning is 15, and the only thing that's left out is the total resistance. Now, since it's a parallel circuit, this is the relationship. 1 over R total is equal to 1 over 20 ohms plus 1 over 13.3 ohms. So simply work that in the calculator. 1 over 20 is 0.05. 1 over 13.3 is 0.0751. So that's 0.125. Interchange with the total resistance, and I get 8 ohms. And of course, as mentioned before, the total potential difference must be 120. Okay, so you try questions 3, 4, and 5. And once again, come check with me. I'll have a final answer sheet so you can check to see how you did. And lastly, we have the vocab here, just one vocabulary term, equivalent resistance, the value of a resistor which represents a bunch of resistors in series or parallel. So of course we have rules for series circuits, rules for parallel circuits, If it's a series circuit, we just simply add up the resistors to get the total. If it's a parallel circuit or parallel branch, the relationship, of course, is 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 if there is one. Okay, so there you have it. That's the last booklet. Again, check with me because some of the stuff can be a little tricky, and I can give you some help. Okay, we'll see you soon.